by delta t. This and this goes roughly, I'm saying. It is not exact case because it is twisted mathematics done here. So for that, I will be equal to delta p. This is what I was telling you earlier, that the product of force and time of action is equal to the change of momentum. So we can calculate the change of momentum. From that, we can calculate the impulse. Fine. So for that, we will solve an example. We'll get clarified further by solving an example. Say, for example, there is a batsman. Here is a batsman with a bat inside his hand. So a bowler here throws a ball towards him. A bowler throws a ball towards him. Say, for example, we are getting this is positive direction of x-axis and this is the negative direction. So ball is thrown like this and this batsman hits it back. Say the initial velocity of the ball is 12 meters per second. Say initial velocity, so u is equal to 12 meters per second, and the batsman pushes it back with the same velocity. So final velocity is also 12 meters per second. But we have taken, since we have, it is just the supposition, we can take positive direction in this case also, in this direction also, okay? It is just for convenience, we are taking it in. So I have told you that the bowler is pushing the ball with a velocity of 12 meters and the batsman is pushing it back with the velocity, same velocity, but in the opposite direction. So in that case, u will be minus times, because we are taking the positive direction in this direction here, just for convenience, okay? So we have to calculate the impulse generated, because force acted onto the body, it's for very much smaller period of time, so time of action is very much smaller, so it is not feasible to calculate the force. So we calculate the product of force and time of action, okay? So that is the impulse, and we know if we are not given the time of action here, we can still calculate the impulse, because we know how to calculate impulse. Impulse is just equal to the, as earlier told you, that it is just equal to the change of momentum, okay? So how to calculate the momentum? We know from formula, we know that momentum is equal to mass times velocity. Okay, so what will be the initial velocity, initial momentum? Pi initial, okay? That will be the mass is 0.415 kg multiplied by velocity. What is the initial velocity? Is 12, but it's minus times 12. Minus 12 meters per second. Fine. And the final momentum will be equal to 0.15 kg into the velocity. Velocity is still 12, but in the positive direction. Okay, that's v. Okay, that's fine. So in both the cases, it is here minus 3.6 newtons. Sorry, what I calculated? Sorry. So we'll get here the initial momentum like this and the final momentum like this. Fine. So now impulse, from here we can calculate impulse is equal to the change in the momentum, and we know change in the momentum is v final minus p initial, and that will be equal to v final will be this much, and p initial will be this much, and both are, this is minus, this is plus. So this is this much of quantity minus times this much quantity, but this is also minus, so minus becomes plus. So this will be 0.15 kg. I will not use the units. 0.515 into 12 meters per second into 0.0 plus here. Okay, it will be plus times 0.15 into 12 meters. This is the initial velocity in the negative direction, and negative becomes positive here. So on calculating, we'll get something newtons second, something Newton second, and this Newton second is the units of impulse. Units of impulse. How to calculate that? We know that impulse is equal to the force, product of force, and the time of action. Time of action. What is the units of force? It's Newton. And what is the time of action? Time units has units second. So that's the units of I is equal to Newton second. That's as simple as it is. Fine. So this was all about the impulse. Fine. Hope you got that. I'll see you in the next.